Thank you. I will talk about impacts of clear cutting of boreal forest on greenhouse gas fluxes, and also try to discuss a little bit if some other management model can, how that affects also the greenhouse gas exchanges between the atmosphere and the ecosystem. So an outline here, I will give some background and describe how the emissions from Sweden's forested area, how large it is based on previous literature studies, and only one case study from clear cut involving also other greenhouse gases, methane and nitrous oxide, and also discuss a little bit about alternative management methods, what they could do, and some conclusions. So we all know how the rotation management works in boreal forests. An interesting question for a scientist working with greenhouse gases is that how does this form of management affect exchanges of greenhouse gases from the mature stand after clear cutting, after regrowth of the forest, and after some thinnings, and finally back to a full mature stand again, and then the rotation starts over again. We work with direct measurement of fluxes, so we put up equipment above the forest, and then we can measure with very high temporal resolution the flux between the ecosystem and the atmosphere, usually half an hour, and then we sum that up to 2 years or more. So that it's a direct method of really measuring the flux between ecosystem and the atmosphere. This is an example of how the carbon balance varies over time as a function of stand age. And this data, or this simple model, is based on results from chronosequence studies that we made in a European project some years ago now. We had 5 different chronosequences in Sweden, Finland, UK, France, and Italy. And it was actually possible to build a model of how the carbon balance varies over time as a function of rotation length and maximum uptake. And this then is an example of how it will look like in a typical Swedish situation with a 100-year rotation time. In the beginning here, immediately after the clear cut, we have high emission. Yeah, I should say also that positive here means loss to the atmosphere, and negative numbers means uptake from the atmosphere. That's a sign convention that we work with this method. So during the first about, well, up to 12, 15 years, we lose carbon to the atmosphere. And then we have a period of recovery, which is about equally long as the loss period. And finally, we get a long period of net gain of carbon. And it turned out that the mean net ecosystem exchange was about 50% of the maximum, which is here. So this is a very general picture of how the system works like. But we noticed that we have a big loss in the beginning, and that one can ask the question, can we avoid these losses of carbon in the beginning? So if we look at results from recent studies on clear cut with the same type of method as I mentioned, direct measurement, these are first-year emissions from 13 different clear cuts, and the red bars are from Nordic clear cuts, Swedish and Finnish, and the green ones are from non-Nordic, mainly from North America. And you can see that there is quite large variation depending on, well, the fertility of the system and so on, moisture of the system and so on. But the average first-year emission is quite substantial, 470 grams of carbon per square meter per year, with a 95% confidence interval of plus minus 171. So it's even if the variation is large, but all systems show a significant loss of carbon dioxide during this period. So I took this data and wanted to scale it up to the whole forested area of Sweden. So here we have the annual emissions during the first 10 years, and I simply assume that after 10 years they would be zero or in balance again. The system would be in balance again. It can be maybe shorter in the south of Sweden and probably longer in the north of Sweden, but it's probably quite a good estimation. And then I just converted this to annual emissions in ton CO2 per hectare. And here we have the area of clear cuts. We have about 200,000 fellings, final fellings per year, but not all of that are clear cuts. It's about 75% that are clear cuts. So first year clear cuts are this amount, and then the second year clear cuts, old clear cuts are this amount, and so on, all up to when they are 10 years old. So then it's just to multiply with these numbers, and we get here in the summary, million tons of CO2 per year. But as you know, this is really a huge number, so it's substantial. But we were also interested in other greenhouse gases, as I said, and we made a study in central Sweden area, not far away from Uppsala, where we had a fresh, both a dry plot and wet plot. And what I call control plots here, that's just clear cut with a traditional way of managing it, with scarification, plantation, and so on after some year. And we did this type of flux measurements over this area. And the results looks like this. These are the wet plots, and here are the dry plots to the right. For CO2, we see very large emissions, especially during the first year, lower during the second and third year, mainly because ingrowth of grasses and bushes and so on that started to take up carbon and compensate for the losses. Methane emissions were they are converted here to CO2 equivalents to be comparable to these numbers. They exist, but they are much lower, as you can see here. And we also saw some N2O emissions, also very low, almost negligible. For the drier plots, we got higher CO2 emissions, which we also expected. We have more oxygen in the soil and more decomposition. And here the methane emissions were lower than on the wet plots, also that's what we could expect. But N2O emissions were, on the other hand, a little bit higher. So we can see that we do get other emissions also from other greenhouse gases, but they are not very large as compared to the CO2 emissions, but they go in the same direction. So one question is, could phasing out clear cutting as a management model be one of several tools to counteract climate change? And one possible option, as we have discussed here also, is management by selective cutting, as you know how that works. Just pick out some trees and leave a large portion of the trees staying in the forest. So from a climate perspective, we have two important questions with this system. What is the impact on the net carbon balance of selective harvest to compare with the emissions from the clear cut? And what is the mean long-term carbon balance of such a system in comparison with rotation managed ones? This is a bit of a problem because almost all of the research that we have done has been done on the rotation management systems. But there are some clues. And question one, we can take thinning as a surrogate for selective harvest. It's not the same, I know that, but that's actually the only thing that we can do. But it will learn us something from that. And if we look at what has been done with this type of method where fluxes are measured directly, immediately after a thinning, there are a number of studies in, not so many in Nordic countries, but we have in Ireland, Sitka spruce, oak in England, beech in France, pine in Finland, and a mixture of pine and spruce in Sweden. And all come to the same conclusion, that we have very small or no significant effects on the net carbon balance for a modest, or a typical, I should say, typical thinning, taking about 25% of the volume or 25% of the leaf area. So that is pointing in a positive direction, that it's none or very minor effect of thinning on net ecosystem exchange in a type of selective cutting forest. So the second question is even more difficult to answer, because we don't have any system to measure on. But it's important to point out that net ecosystem carbon balance is important, since it includes both the fluxes from the soil and the ground vegetation. And this is often omitted when you talk about what is responsible for taking up the carbon. It's not only the trees, also the soil and understory vegetation is important. And the commonly heard statement in Swedish debate is that long-term volume growth in selection managed forests is much lower, 10 to 20%, as compared to rotation managed forests. But there are other studies contrasting results, in example from Finland, for instance, showing that uneven age stands grows faster than even age stands. And in a recent study based on quite a large material and with simulation models, they show that the carbon balance of selection forestry is on average 35% higher as compared to rotation managed. And this gap between the methods corresponds very well with the non-existent clear-cut emissions in the selection managed system. So conclusion 2 here is, although there is no consensus regarding managed forests should have a higher net carbon balance over the long term as compared to rotation managed, but there are some results that point in that direction. So my conclusions: a case study shown that it does exist emissions of methane and nitrous oxide from a clear cut, but the magnitudes are small as compared to the emissions of CO2. And that the CO2 emissions from clear cuts of the whole area of Sweden clearly shows that clear cutting is a no-go option, considering the short time frame we have to reach the goal of no net emissions by 2045. Also very well illustrated by the recent IPCC report. And emissions from clear cuts can be avoided by changing management from rotation to selection forestry. This switch can be done instantly by banning clear cutting. So I have some reference here that you can find in my presentation later. And that's all for me. Thank you very much for your attention.